Predictive products made when reacting 1-butanol with all of these. Well, first of all, let's think about what they do. One of the huge things with organic chemistry is to recognize the reagents. Concentrated sulfuric acid will dehydrate. Okay, so you'll go from the alcohol to an alkene. SOCl2 is a great chlorinating agent, so we'll substitute the OH with Cl. KBrH2SO4, one of the many brominating agents, so we'll put a Br instead of the OH. K2CrO2O7 acidic solution oxidizes. Now, even though I'm supposed to be training you for A-levels, I really want to get it straight that this is a strong oxidizing agent. It's not going to partially oxidize something. If you want a partial oxidation of a primary alcohol, you will use this PCC in anhydrous conditions, as we discussed in the movies. Well, anyway, let's see what happens when we take 1-butanol and we dehydrate it. So we'll lose the OH off this and then an H off that one. So we will make 1-butene, but-1-ene. Substitute Cl, fairly straightforward. We'll just make 1-chlorobutane, 1-bromobutane when we do the bromine. Now let's oxidize. Well, it's a primary alcohol, which when we oxidize it fully, turns into the acid, so butanoic acid. When we have a mild oxidation of a primary alcohol, we'll turn it into the aldehyde, so butanal. 2-butanol, so now we have a secondary alcohol that we'll have to think about. Dehydration, concentrated H2SO4. Well, we're going to remove this OH, but then we actually have 1 hydrogen there, or 2 hydrogens, or 3 hydrogens that we can remove. So if we remove one of the blue hydrogens, then we'll make this, which is just simply but-1-ene. If we now remove either the pink or the purple one, then we will make either the Z-but-2-ene or the E-but-2-ene, depending upon which one you remove. So very, very careful when you're dehydrating how many hydrogens you've got, different types of hydrogens you've got on the carbons next to the OH. Which of these will be the most stable, the best product? Or we think about Zaitsev's rules that says, first of all, most substituted, which knocks out the but-1-ene. And then when you've got the choice here, you will always go for the E rather than the Z. Continuing on, SOCl2 just pops in a chlorine instead, so 2-chlorobutane or 2-bromobutane when we do that one. Now, oxidation. What we got here is we got a secondary alcohol. When you oxidize a secondary alcohol, you make a ketone. And you can use either of these oxidizing agents to make 2-butanone, but-2-one, or in the old days, we would call it ethyl-methyl ketone or methyl-ethyl ketone, as things would take you. Finally, tert-butyl alcohol. Like to use these old-fashioned names. There's the tert-butyl group with an alcohol on it. Better these days, you would say it is 2-methyl-propantuol. So anyway, let's dehydrate this, remove the OH and any one of the hydrogens, because all of these methyl groups are the same. So that would give us the 2-methylpropene. Substitute in chlorine, bromine, so we would have the 2-chloro, 2-methylpropane, or 2-bromo, 2-methylpropane. Now, oxidation of a tertiary alcohol doesn't happen. I mean, it does, but it gives you all kinds of funky mixed products that we don't worry about at A-level, so we say no product at all.